Guys, we're going to do another example on chapter 11, confidence intervals. Let's see. We're going to go to Emily's question in my stat lab. This is okay. So a random sample. Where is the sample? They give us the summary. Okay, so we're asked to find the confidence interval. And again, to repeat, the theory or the explanation of the concepts are found in my YouTube videos. But where we know an average is 3.59 with a certain range, because some gasoline stations charge more, a little more, or a little less. So we want to have a number that represents the average of the whole population, but not just a specific number, which will maybe only apply to a few, but that we're pretty sure that the average of the entire population is somewhere between. And that's what a 95% sure. Anyway, we're going to go into StatCrunch, get more help, StatCrunch. And it's not opening. Afraid of that. So we go an alternative. We go to StatCrunch directly. StatCrunch.com. We go into open stat, sign in. This is sign in. Open StatCrunch, which of course we can get to directly in most problems. And we're going to go to stat. We want a t-stat because the confidence interval involving a standard deviation of the sample involves t. If it was the population, it would be a z, as in zebra. We seem to have one population, and we don't have the raw data. We have a summary. So you plug in the average, which is, in this case, where's that? Oh, it's messy here. Yes, my instructor. The average was, sample size is 20, 359.28. 359.28. Oh, this is messy. TechCrunch. 3.59. 0.28. 20. Confidence interval, actually 95%. Compute. And it goes from 3.45. Copy. Place it into the lower end. And the upper end was 3.72. So we're 95% confident, which we'll talk about, I think, in a second, what that means, that the real average of the population, if we took every single gas station in the country or the area. Okay. Now we want the same thing for 90%. 90%, you go back to StatCrunch. We go to stat, T, one sample with data. Sorry. Stat, T-stats, one sample with summary of the data. 3.59.28, 20. Confidence interval this time is, we want to be a little bit less confident, but we're going to get a more precise interval. The interval smaller. Compute, and this time it's going to be 3.48, a little closer to the average. Copy. Isn't this great? No formulas. The upper end of the interval is here, 3.69. Control C. This is the slow part of this. Control V. Check answer. And we're now, if we had the same statistics from a sample of 40, what would it be now? I mean, do we really have to do this? You repeat. Whoop, get rid of this one. Start again. Stat. Summary stat. I'm sorry. T stat. One sample with summary. 3.59.28. This time the sample is 40, and of course, because the formula with a larger, think about it, with a larger sample size, your results are more precise, and therefore you can be the same amount of confidence, 95%, but it means your interval will be smaller. In other words, you can narrow it down, and actually, there's a square root of n on the bottom of the formula that instrumentalizes that. Now it's 3.50, copy, to 3.67 or 3.68. Let's do that quickly. Control V, 3.67, I think I said. So the numbers are right. That's it. Well, that was easy. So let's stop sharing. Let's close off the meeting.